Hello friends, welcome to Chance Code. Kotlin lets us write functions locally inside other functions. In this video, we are going to explore this feature of Kotlin and understand how local functions are supported by Kotlin as a feature even though JVM doesn't support it. So let's get started without waiting further. To understand how local functions are being supported by Kotlin, I have taken this small example. Notice that the condition inside if is calling a function called validate, and the function is declared locally inside the login function. As far as JVM is concerned, it cannot understand validate function as it is not supported by it. Then the question is, how does this work? Of course, Kotlin compiler does something under the hood in order to make this local function compatible with JVM. And to understand what Kotlin compiler does under the hood, let's try to convert this Kotlin snippet into Java snippet line by line. So the signature of login function looks something like this. Similarly, the body of if is converted to something like this. And the println gets converted into system.out.println. Now let's convert the actual thing, which is the validate local function. Let's first convert its signature, which looks something like this. And similarly, the body gets converted into something like this. I am not explaining all these conversions in detail because this is not the topic. Now let's come back to the topic and answer how this validate function can be inside login function. Of course, we cannot write something like this if you want this code to be JVM compatible. So what Kotlin compiler does is it separates the validate function out of the login function. Since there is no concept of functions in Java world, the validate function cannot stand alone. So it has to be wrapped inside a class, and the class looks something like this. Observe closely that the class which wraps our local function validate is something which extends lambda and implements an interface called function1. And the reason why it is implementing function1 is because the validate function accepts only one argument. Let's skip the body part of validate function in order to have more space. As the generated class is something which can be represented as a lambda, Kotlin compiler changes this method name to invoke instead of validate. So far we have understood how the declaration of local function is being converted into a class. Now let's go back to the login function and understand how this function is being called. Since there is no more validate function, obviously Kotlin compiler has to do something about it. Just for the sake of example, I am giving the name of generated class as validator. Of course, validator is not the name which is generated by Kotlin compiler. Since there is no more validate function, moreover the functionality of that function is wrapped inside the validator class, so it has to create the validator object. And instead of calling validate method, it has to call invoke method. Now we have reached into a place which is completely compatible with JVM. Notice that there are two objects of validator is being created. So of course there is a problem with respect to performance. And to solve this performance problem, instead of generating the validator class as a normal class, it generates it as a singleton class. And the constructor of this validator class looks something like this. Notice that the body of validator constructor calls to its superclass constructor by passing 1. And that is because the invoke method defined in validator class is accepting one argument. Coming back to the login function, instead of creating two objects of validator, now we have an instance variable which can be accessed. And to make it more optimized, this instance can be stored as a local variable. And this is what Kotlin compiler generates under the hood for us in order to support local functions. But before I wind up this video, let me show you some interesting stuff. And for that, let me go to my IDE. In order to prove that the validate function which is declared locally in the login function, it's making the Kotlin compiler generate a class to make it JVM compatible, I have taken you to my IDE with the same example. Notice that the name of this Kotlin file is localfunctions.kt. I have created a Java class called as local functions. Now let's create the main method here. And the interesting thing I want to show you here is I'm going to call the local function validate from here. Since the validate function returns a boolean, I will create a variable for that. As we have already discussed that validate function is converted into invoke method by Kotlin compiler, let me call the invoke by passing a string value called as 10. Since the invoke method is part of a class, let me call it through an object. And for that, let me use the name of that file, which is local functions, postfixed with kt because it is a Kotlin file, then the login function separated by a dollar, then 1 separated by dollar, and the reason why I have used 1 here is because the validate function is the first local function inside login function, and this is what is the exact name of generated class which we have declared as validator for the sake of example in the slides. Since this class is a singleton class, let me call the instance property of this and then call invoke method, and finally let me print the output. Now let's execute this main method. As you can see, I have got the proper output in the console. Now let's try to update the input and see what is the answer. And here is the new output. Now let's go back to the slide. I hope I have explained the internals of local functions very well. Moreover, I have tried to show you that local functions are not completely private to the functions where they declared inside. And for that, I have taken you to my IDE to show an example by abusing this feature of Kotlin. Of course, that was just for the sake of demo purpose. Please don't try to abuse the local function feature like that. Hope you learned how local functions are getting converted into classes in order to make it JVM compatible. If you learned something new out of this video, please do like, share and subscribe to my channel. Thank you. Thanks for watching.